You see it every single day, right? Headlines that start with "a new study finds" or "statistics show." But have you ever stopped to wonder how they actually get those numbers? Well, today we are pulling back the curtain. This is the Researcher's Playbook, and it's all about helping you understand the stats you see every day. It all starts with one really simple question.
This right here. This is the big one. When you read that, coffee drinkers are more productive, or that a certain new habit lowers stress, the absolute first thing you should ask is, who did they actually talk to? Because the answer to that one question, well, it changes everything.
And that leads us right into our first major idea, figuring out who to ask in the first place. Before any researcher can find an answer, they have to make a huge choice. Are they going to try to study the entire big picture? Or are they going to take a small, focused snapshot?
So in research speak, that big picture is called the population. And this doesn't just mean how many people live in a country. It's the entire group you want your study to be about. So if you're looking at coffee drinkers in Chicago, your population isn't just a handful of people. It is every single person in that city who drinks coffee.
Now, you can probably guess that trying to talk to every single coffee drinker in a huge city is, well, pretty much impossible. And that is where the sample comes in. The sample is just a smaller, manageable chunk taken from that much bigger population. The whole goal is for this one little snapshot to perfectly represent the entire photo album. And that's really the bottom line. We use samples because we have to. It's just way too expensive, it takes too much time, or it's just physically impossible to get data from everyone. So the hope is that this small, carefully chosen group can tell us something true about the whole population.
Okay, so we know we need a sample, but how do you actually pick the people who are in it? This is maybe one of the most important decisions a researcher makes, and it really boils down to a fundamental choice. Do you give everyone a fair chance, or do you make a fast choice?
These two approaches have official names: probability and non-probability sampling. With probability sampling, every single person in that big population has a known, fair shot at being picked. It's truly random. Non-probability, as you can guess, is the opposite. The selection is not random, which means some people have a 0% chance of ever being included.
Let's look at how these fair chance methods work. The most basic one is called simple random sampling, and it's literally like pulling names out of a hat. Everyone has the exact same odds. But a smarter way is stratified sampling. That's where you first split the population into important subgroups, like by age or location, and then you randomly pick people from inside each of those groups. That way, you know for sure your final sample is perfectly balanced.
Now, on the fast choice side, you've got things like convenience sampling. And it is exactly what it sounds like. Researchers just go talk to whoever is easiest to reach, maybe people walking through a college campus or a shopping mall. And then there's a really interesting one called snowball sampling. That's where you find one person and then ask them to refer you the others they know.
And it turns out these fast choice methods can be absolutely necessary. I mean, think about it. Snowball sampling is incredibly useful when you're trying to study groups that are hidden or really hard to find. You start with one person, and they lead you to others, and they lead you to more, just like a snowball rolling downhill picking up more snow as it goes.
So why are we getting so into the weeds on this? Because the sampling method is everything. It's the foundation of how much you can trust a study. A random, fair chance sample is way more likely to represent the whole population, which means you can be pretty confident in the results. But a fast choice sample, well, could be biased, and its findings might not apply to anyone other than the specific people they happen to talk to.
All right, so you've picked your group. What's next? Well, now you have to decide what you're actually going to measure. And in the world of research, this really means identifying the cause you're curious about and the effect it might have.
The things we measure are called variables, and they basically come in two main flavors. First, you have qualitative variables. These describe a quality or a category, things like your gender or your blood type. Then you have quantitative variables. These are the ones you can measure with numbers, like height, age, or temperature. Just think quantity. Now, this is where it gets really interesting. Most of the time, researchers are looking for a connection between two special types of variables. The independent variable is the thing they think is the cause, and the dependent variable is the effect. It's the thing they measure to see if it changes based on that cause.
Let's make this super simple with a real-world example. Imagine a study asking this question: what is the effect of fast food on blood pressure? Take a second. Can you spot the cause and the effect in there? You got it. The independent variable, the cause, is how much fast food someone eats.
That's the factor we're looking at. The dependent variable, the effect, is their blood pressure. Its value depends on the fast food. See how that works? It's pretty straightforward when you break it down like that. So, let's recap. Our researchers have chosen their sample, and they've measured their variables. Now what? Now they're staring at a giant, messy pile of data. The last step in our playbook is to turn all that chaos into something clear.
And this is often what raw data looks like, just a jumble of numbers. Here we have the ages of 25 staff members at a university. Just looking at this, can you quickly tell me what the most common age is? Or even what the general age range is? It's tough, right? It's basically just noise.
But watch what happens when we just organize it a little. This is called a frequency table. All it does is list each age and count up how many times it shows up. All of a sudden, the chaos is gone. You can instantly see that the age 47 appears 6 times, which is more than any other. Just like that, we have order.
And we can make it even clearer by turning it into a picture. A simple bar chart tells the whole story in a single glance. You don't even have to read the numbers. That tall bar for the age 47 just jumps right out at you. Our brains are built to see patterns, and charts like this make those patterns impossible to miss.
And that right there is the magic of what's called descriptive statistics. It is the art of taking a messy pile of raw numbers and summarizing it in a way that tells a clear, simple story. It's all about finding the signal inside all of that noise.
So there you have it. That's the playbook. Now you know that behind every single statistic there's a population and a sample, there's a method for choosing them, and there's a way of measuring and telling their story. So, the next time you see one of those big headlines with a brand new statistic, what's the very first question you're going to ask? My guess is it's going to be, yeah, but who did they actually talk to?